All right, here we go. I'm going to see if I can get that focused a little bit better. There we go. All right. Okay, so elimination method. All right, so remember in the elimination method, you keep your X's and Y's and you still cancel them, you just write them. The other thing is it doesn't matter which one you cancel first. So if you're like, oh, the Y's are easier, I'm going to do that first. It doesn't matter. So I kind of like the Y's better on this one because one's positive, one's negative already. 3 times 2 is 6. So negative 6 is a good choice. So I'm going to multiply by 2, 2, and 2, 3. Let's see, 3 and 3. So what do I get? I get 4x, negative 6y, 28, 9x, 6y, and negative 15. I get 13x. These cancel, which is what we wanted. And I get 13 and then divide. X is 1. Okay, yay, I know X. Now, for me, I prefer just subbing back in to get the Y. So I'm going to take that and put it right back in there. So 3 times 1 plus 2y equals negative 5. So that's just a 3. Get rid of 3. I'm going to subtract it or do a negative. Debt and debt makes more debt. And then I'm going to divide and I get negative 4. So there's my answer. Now, some people like to cancel the x's first, then cancel the y's later to get both the x and y's. That works too. Okay, we'll talk about checking in a second. All right, the next one is fake Gauss Jordan pivots. This is matrices. Very similar, except you don't get to write the x's or y's. So I have it in the order of x, then y, then my equals 2 over here, and the x and the y. And order matters, so you got to line them up first. Okay, so in this one, you have to pivot here first. No choice. You can't be like, well, I like this better. It doesn't matter. You go down the diagonal. All right. So if you don't know what to do, what's 2 times 3? 6. Use 6 and a negative 6. Okay. So I am going to multiply the top one by 3 and the bottom one by negative 2. But before I do that, my pivot row is permanent. So you can change on scratch paper, but not in the real matrix. You got to leave it that way. So I'm going to rewrite it first. Okay. So now what am I going to do? Well, I want to do, let's see, I'm going to multiply the top one by 3. And this pen, I need to ditch that, I guess. I was going to switch colors for you. 3, and I'm going to multiply this guy by negative 2. And I think I'm going to just give up on the color coding here and go back to my blue. All right. So on scratch paper, I get 2 times that 3 is 6. Negative 3 times 3 is negative 9. And that times that is, I think, 42. This times this, negative 6 and negative 4. And a negative times negative is a positive. So then I'm going to add down. So I get 0, debt and debt makes more debt, and I get money and money, more money. So I have 0, negative 13, and 52. Now, technically, if you want to divide here because it's pretty, you can, but I'm not going to do that. I'm just going to stick with the real method. So the real method says, or I guess the fake real method, but I'm going to go down the diagonal. All right, my pivot row is permanent. Do not mess with it, except on scratch paper. All right, so now my pivot is between these two. So the easiest thing to do is take 13 times 3, 39 and negative 39. Sometimes something smaller might work, like 26, but notice I can't make that a 26. So 39 is my best choice here. So one of them you want to multiply by a positive, one negative, but the problem is they're both negative already. So I have to think, I want a positive, negative, how am I going to do that? So I'm going to go ahead and multiply this guy by 13. All right, so that's going to give me 26 on scratch paper, negative 39 on scratch paper, and 14 times 13 is 182. Now, since that's a negative 39, I need this to turn into a positive 39. So I'm actually going to multiply by a negative 3 because I need it to get the opposite. So this is 0, positive 39, and 52 times 3, I think that's a negative 156. All right, go down. These cancel, which is what I wanted. Let's see, 182 minus, what was that, 156 is 26. Okay. So that's my new row 1. Now I've done my pivot. I pivoted there and there. Now I'm ready to divide. So to get a 1, 26 divided by 26 gives me my 1. To get a 1, you divide again by itself. So negative 13. So I get 1, 0, 1, 0, negative 1, negative 4. Oh, that's not negative 1. Sorry, there's my negative 13. That has to be a positive 1. Otherwise, I screwed up my pivots. So then you can read off your answer. X is 1 and Y is a negative 4. Now, as far as checking, what can you do? Okay. One thing you could do is sub in both of these answers into both equations and make sure they work. It has to work for both. The other thing is you could graph them, right, and see where they cross. Okay. Another thing is you could put this into Desmos as a matrix and do RREF. So lots of ways to check your answer here and then find your error. All right, let's look at this one down here. Okay, and I don't think there was an N. All right, so in this one, these two matrices are equal. So this is more like the chart kind, like matrices and, you know, keeping track of twin and full and whatever. But it's saying this element has to equal that one. So each of the little pieces have to equal. So subtract 5, is that negative 12, I think. If I make a dumb mistake, you can let me know. 3b is equal to what? B plus 2, because they're in the same location. Again, in algebra, you move variables by adding or subtracting. And then because I'm undoing multiplication, I'm going to divide. So it looks like B is 1. This one over here, all of this has to equal that. So I'm going to set them equal, add that 3 over because that's how we do algebra, and divide by 2. And you could either put 9/2 or 4.5, you know, either way. You don't want to round. So if it's not a pretty decimal, you know, you should probably use a fraction. All right, there we go. All right, let's look at this one. All right, so that one lines up there. So 4c equals 3, divide by 4, divide by 4. C is either 3, 4, so you could put 0.75, same thing. The middle one, this guy is equal to that guy. All right, bring your D's over. I'm going to bring them to this side. Oopsie, I should have a D there, sorry. So D's cancel, let's see, 2 dogs minus dog, you better have 1 dog, right? And then add the 1 over to get D is 3. And if you're not sure, you can check it. That's 5, 6 minus 1 is 5. Oh yeah, that'd be the same, right? Negative 3 is 4L. So divide both sides by 4. L is, what, is that right? Negative 3 and 4L. So L is a negative 3/4. I feel like, did I do some? No, I think that's okay. All right, double checking myself here. M is a negative 1. 4p looks like if 4p equals 12, I could just divide by 4 and get 3. So that's that one. And then q minus 1 is 8. So to bring that over, you just add 1 to both sides. So it looks like that's 9. I just don't remember having 2 3/4, but I probably did. So yeah, if there's an error there, you guys are going to have to keep me on the straight and narrow because I'm not seeing it right now. All right, so that's just kind of more algebra and knowing that the pieces have to match. All right, let's look at the next page. All right, so here's this one. All right, so let's look at this guy. All right, so A plus B. Well, A is a what? A is a 3/2, and I'm trying to combine it with B, which is a 3/3. Think of like the matrices. This is more that kind of thing. They don't line up. Like you have this whole extra column here. So not possible. And the reason is they have to be the same size. Okay, so when you're adding, they have to be exactly the same size. All right, let's look at A and C. So I have A, 4, 10, negative 2, negative 3, 6, and 9, minus C is 5, 0, negative 1, 3, 4, 7. Okay, these are the same size, so I can, you know, subtract. Now, if you like to take 4 minus 5, 10 minus that, you can do that. I like to add the opposite. And again, I'm going to use my bad black pen. I would rather add, make this negative, that you can't make negative, positive, negative, negative, negative. My brain just likes that better, but up to you. So 4 and a negative 5 is, I just think of money and debt, so that's a negative 1. Let's see, 10 and 0 is 10. Oh, $2, have a dollar, that's a negative 1. Oh and oh, I owe more. 6 and debt, what would that be? $2. 9 and debt, I would have 2. Okay, and if you're not great with integers, you can use calculator. All right, so this is a negative 1. All right, let's look at A times C. A is, again, RC cola. A is 3 by 2, and C is what? 3 rows, 3 by 2. All right. Now, they're the same size. I could add or subtract them, but I want to multiply them, and to multiply them, these have to match. So this one's not possible. And you could say, you know, inside numbers don't match. The other thing you could say, because this is RC and this is RC, you could say the columns of the first do not match the rows of the second. You could do that too. That works. All right, look at this one. A again is 3 by 2, right? And F is 2 by 2. All right, so see how the inside numbers match. That's good. That means I can do it. The answer is going to be 3 by 2. So I know that. All right, and I am going to write these next to each other so I can do my math. And oh boy, I don't know if I have a sticky note. Might be in trouble here. All right, do I have sticky notes around here? Oh, lucky day, I do. All right, okay. So kind of a big sticky note, but it's a sticky note. So it's all about RC Cola. So I'm going to do rows, columns. Remember, it's all about RC Cola. So I'm going to take 410. So I'm going to turn the row sideways. Okay. And I know my answer is going to be what? 3 by 2. Okay. So here I get a negative 4 and 30. So I get 26. Come over here, I get 16 plus 70. So that's what? 86. And I'm done because I don't have any more space. All right. So I'm going to cross that off. And my next one is what? Negative 2, negative 3. So I'm going to take this row by the columns. So what do I get here? Here I get a negative times negative is a positive 2 and a negative 9. That's a negative 7. And here I get a negative 8 and what? Negative 21. I think that's a negative 29. All right, and then the last one, I'm going to take this row and do all the columns, RC Cola. So I get what? Negative 6 and 27. Is that 21, I believe? And I'm going to take 24 and what? 63. Boy, I think that's 87. Okay. All right. So to check my answers on these, I could go on to Desmos and type them in and see what happens, right? And then if I made a mistake, I'll fix it. On the test, I do expect you to show me scratch work to prove that you're, actually doing the math and not just using Desmos. All right. Normally on these, if you're going to use a calculator, we do RREF. But on here, I want you to use the A inverse B method. This is all Desmos. All Desmos matrix, nothing by hand. The A matrix is your coefficient matrix. It's the 5, 3, 10, negative 2. That is the numbers in front. That's called the coefficient matrix. The variable matrix are your X and your Y. And then the other side, I guess I could have put B over here, but the B matrix is like your totals, right? So it should kind of match like, I don't know, 10x equals 30, where you have a coefficient variable and then like equals 30 would be comparable. So this is like your coefficient matrix, variable matrix, and total matrix. It's just, obviously, these are numbers. This is matrices, all right? Then on Desmos, just do A inverse times B, and your answer should pop out. I don't know if this thing, okay, sorry there, I had to glitch it to get to Desmos. Okay, so what I did is I edited A, edited B, and did A inverse. So I hit A, the inverse key, times and then b, and then in this method it spits out the answer. All right, so let me show you. So on your paper, just write, x is 34, y is